Or those who think they're innocent.
Yeah. Oh, yeah.
Or claim to be innocent.
It's amazing how quiet it gets as soon as we go live.
It is the 18th. It's the 18th Astronomical
Yes.
League Live, right?
Yes, it is.
All right.
Now, Caitlin, how did you do that? You showed up again.
Just unlogged,
Good.
logged out and logged back in.
No, I'm
Yeah.
magic. No, I need to log in with my computer because my camera and my computer don't talk to each other.
Oh,
So I'm double trouble tonight.
okay. Well, I'm not sure we can handle double trouble.
Well, we'll figure it out.
Yeah.
It'll be fine.
So yeah, so you're on two separate computers right now then, right?
Not necessarily. I have my like phone camera and then my computer.
Okay.
So it's just one computer that I'll show the slides, but you'll still hear me.
Okay.
So it'll be
fine.
Yeah.
It'll be fine. That's right.
Yes.
Yeah.
We
I mean,
need a little.
I've had to do this on Global Star Party before too, so Scott knows that I show up double every time too.
Mm-hmm.
So
it's a good
that's
way
interesting.
to do it, though, I think. I think it's a good way to do it, is to have two, you have one that's doing your presentation, the other one's you.
Yeah. So this is like my personal setup, because otherwise my work setup is slightly different.
Now, at work, can you use Zoom, or do they use something else?
We can use Zoom, but not necessarily. It's frowned upon.
I see.
I prefer Zoom by all means, but no. For work, they have us use Teams.
Yeah, it seems like a lot of the workplace does use Teams, and I am so used to Zoom. When I have to go on Teams, I get kind of confused because I'm so used to Zoom.
Mm-hmm. Yeah, I definitely prefer Zoom as well.
Yeah. Carol, you look like you're just gliding along the Milky Way there. And you're muted.
You're muted.
I wish I
can tell
were.
you Is it still 100 degrees out your way?
Yeah, the car said a few minutes ago 102. So.
Oh my gosh. Oh.
Carol,
and it's not dry heat like where Goddard lives.
Yeah, that's true.
Actually, we're getting rain today, finally.
Really?
Yes.
Well, that's encouraging.
Yeah, we're getting today and tomorrow supposed to be rain.
Well, that's good.
You may have to get out your boat.
The temperature was 111 yesterday.
Oh my gosh.
Yikes.
Wow.
That's too hot.
Yeah, I've got 80 degrees right now, so it's dropping a little bit here.
Wow.
Yes, it's cool here.
So David, in your experience, what's the hottest it's been out in Arizona?
I think we had 115, 116 once.
Oh,
Yeah.
wow.
If it's much warmer than that, they have to close the airport because the ground is too hot for the planes to land. But
I've never heard of that.
yeah, that's happened in Phoenix, and I think it's happened here once.
NASA's explorers on Mars are on the move and making new discoveries. It's a journey you can be a part of too. NASA's Curiosity rover, which has been climbing Mount Sharp since 2014, is about to drive up onto a broad, sloping surface called the Green Hue Pediment. This will allow scientists to fast forward perhaps millions of years in Mars's history and study the history of liquid water written into these different layers of rock. And Curiosity made some interesting discoveries along the way. Less than half an inch in size, this unusual feature, eroded from sedimentary rock, was cemented by mineral-rich groundwater. And check out this rock, smoothly eroded by winds. Over in Jezero Crater, the Perseverance rover is getting ready for a new destination and science campaign. And it's consistently setting driving records on Mars by relying more on self-driving software that allows the rover to avoid obstacles without having to consult a human on Earth. Perseverance will be pushing north in an area where an ancient river flowed into a body of water. It left sediments in a shape called a delta. The rover will collect more rock samples there. The Ingenuity Mars helicopter will support Perseverance's upcoming science campaign. The helicopter has been given the green light to try to keep flying on Mars for the next few months. Upgrades to its navigation software will improve flight and operational safety. The Mars explorers will document the journey along the way, and you can make your own discoveries. Visit the raw image pages to see the latest images every day, and vote for your favorites. To get the latest updates, follow @NASAJPL and @NASA Mars on social media, or take a deeper dive on the mission websites at mars.nasa.gov.
I love that little animation. Well, anyways, here we are with yet another Astronomical League live. I've got Terry Mann here with me. Let me bring her in. Terry Mann puts these programs together, and it's a pleasure to broadcast them here from Explore Scientific. She has a great speaker here, Dr. Caitlin Ahrens. I'm going to let her introduce her, and Dr. David Levy is with us, and the president of the Astronomical League, Carol Orge, is here, and Jim Fordyce, who is also a key figure in the Astronomical League. So I'm going to turn it over to you, Terry. Thanks for bringing it on.
Yay. Thank you, Scott. It's always great to be here. I hope everybody's doing great tonight. So David, how about if we turn to you and have you kick off our show tonight?
Well, thank you so much. Thank you so much, Terry. And it's good to be here to be with the Astronomical League at their monthly online meeting. Today's quotation is going to be from Shakespeare, and it's going to be from his Sonnet 14. Not from the stars do I my judgment pluck, and yet methinks I have astronomy, but not to tell of good or evil luck, of plagues, of deaths, of season quality. Nor can I fortune and to brief minutes tell, pointing to each as thunder, rain, and wind. Or save with princes, if it shall go well. I oft predict that I in heaven find, but from thine eyes my knowledge I derive. And constant stars, in them I read such art as truth and beauty shall together thrive. If from thyself to store thou wouldst convert, or else of thee, this I prognosticate, thy end in truths and beauties, doom and date. Thank you, and back to you, Terry.
Thank you, David. It's always such a pleasure to have you on AL Live. We really appreciate you being here. And actually, you and Scott, there's a star party coming up, isn't there?
That's right. We have, you can see the little poster behind me here. This is the David H. Levy Arizona Dark Sky Star Party #2. We had one before COVID descended upon us, and we're now having our second one. This will be at Oracle State Park, which happens to be the first state park in Arizona to be designated a IDA, International Dark Sky Site. We'll be doing this in tandem with Biosphere 2. So it's going to be a great time, and the whole community is kind of getting excited about it. We're expecting musicians, artists, of course, astronomers, and some great speakers. So it should be really cool. We'll do a kind of like a global star party from Biosphere 2 itself. So we'll see how that goes over, but I think it's going to be great, and I'm excited about it. I will have just come back from the Starmus Festival in Yerevan, Armenia, and that is, if you guys are, good at searching on the internet, look up Temple of Garni, Garni. That is where we're going to be holding the star party there, and apparently this temple that was built was done in the 1st century AD. So it's going to be very interesting. I've never done anything quite like it before, so we'll see how it turns out. But it'll be great to get under Arizona dark skies on my way back, and to meet with David Levy and go observing with him again. So
Yeah.
That's
What's
it.
the date, Scott?
What's that?
The dates?
It will be July 21st through the 25th.
Oh,
Yep,
September.
Oracle State Park, City of Oracle.
Scotty, you mean September, don't you?
I'm sorry, you're right, September.
Do you know where you're
No,
at?
I moved it ahead. Sorry, everybody that bought tickets. I didn't mean to give you a heart attack. So, yeah, but tickets are for sale, and you can go on to explorescientific.com/events. I'll put the link up there for you guys in chat. But it's going to be an awesome event, and if you've not had the chance to observe with David, you're going to want to do it, because it's it's just a lot of fun. So
Yeah. You going to be doing a book signing too, David?
I hope so. I hope that I'll be able to.
Yep.
Certainly have my biography is out. And I'm hoping that my next book for children is going to be out
I hope so too.
certainly by the end of the year.
Oh, that sounds good. That sounds really nice. So, all right. Well, thank you both and appreciate it. David, like I said, we really appreciate you being here. It's always great to see you.
Thank you. My pleasure.
Yeah. Tell Wendy hi for me too. Okay. All right. Carol, I'm
Wendy's
going to.
listening, and she says hello.
Oh, good. Thank you so much. I'm glad she's listening.
Yeah.
All right, Carol, how about what's going on out your way in Kansas?
Well, a lot of stuff going on, and we've had tons of Zoom calls with the league the last week or two. I think we're almost fatigued out, but this is the special one, so we've got to be here tonight.
That's right. Yes. Yes. I don't have to take any minutes, so it's good.
Hey, that's all good. One of the things that I've been thinking about lately is increasing the size of the umbrella of the AL more than it is already in lots of different areas. One of which is many organizations have a series of scholarships that they have available through individual clubs or individual members that they have set up for specific purposes. And so I'm going to introduce that at one of our next EC meetings, council meetings, just to see if there would be the interest in setting up something like that. As things change, I think we really need to somehow come up with a way of having more ownership with our individual members with the league, so we can see that they are connected more directly than it seems to be. Another thing that's just come up within the last little while is the idea of Astronomy Day. And I'm sure many listening out there have been involved in Astronomy Day. In fact, we usually have about 3 or 4 of our league clubs, and many of those are in the Midwest, but some even foreign clubs who get involved in that. And Astronomy Day is held in October and May each year. However, lately with COVID, we haven't had much response. So we're going to retool it a little bit and put an extra push on to really get people doing that again. The reports that are coming in and continue to come in are that we're getting somewhat back to normal, and we're able to have the public around for those kind of events. So we've sort of got out of the habit of doing an astronomy day officially, letting the neighborhood and the community know what astronomy is all about, and maybe having your telescope set up with a proper filtering, showing the public views of the sun with the proper protection, sunspots with always a hit, and doing all sorts of educational information to go along with it. So that's the thing we're going to be emphasizing in the next couple of months. Hopefully we're going to get back in the mode of having astronomy days that people are actually participating in. So stay tuned on that. The other thing I'd like to mention, and I'm not going to take too much of Jim Fordas's thunder, but I'll just want to mention that at ALCOM this year, at the end of next month, I will be hosting a president's panel on diversity. And I know we talk a lot about diversity. It takes so many different forms in society as well as in the Astronomical League. So we're going to have a good discussion about that and see if we can maybe translate some of the words into actions during the next few years, so we can really have an AL presence that looks more like what our country looks like. So let's see if there's anything else. I think that's about it. And I'm sure Jim is going to say more about this a little bit later, but I would encourage everybody to get in there and register for ALCON 2022.
Mhm.
And I understand that for the large array, there may be some restrictions that Jim will be talking about, I'm sure, just a little bit later. Back to you, Terry.
Okay, well, thank you, Carol. Appreciate it. And we do hope to see everybody in Albuquerque. It'll be nice to see everybody face to face. So, all right, I am going to start this, and I am going to ask the questions for tonight once I get everything where I need to get. Tonight's door prize is going to be an Astronomical League tote bag, and 3 people will be receiving 1 tote bag. And they always ask me to mention that there are problems when we ship internationally. So if it takes a while, just let us know and we will give you shipping information. But sometimes we are running into problems when we do ship internationally. So, all right. And please send your answers in the next 30 minutes. This isn't like the GSP. The winners will be announced tonight. And when the winners are announced, somebody from the league's national office will contact you to get shipping address. So, questions for tonight, please send your answers to secretary@astroleague.org. First questions: how many galaxies does the latest estimate say that there are in the universe? How many galaxies does the latest estimate say there are in the universe? And again, send your answers to secretary@astroleague.org. That's the first question. Second question: on July 17th, the moon passes 3 degrees south of which planet? So I'll repeat that again because we've been told we run through the questions too quickly. On July 17th, the moon passes 3 degrees south of which planet? Question number 3. On Sunday, June 12th, the Perseverance rover rolled up to some odd and intriguing Martian terrain. What did it snap a picture of? And please send your answers to secretary@astroleague.org. So let's do that one more. On Sunday, June 12th, the Perseverance rover rolled up on some odd and intriguing Martian terrain. What did it take a picture of? All right, and that will be the end of that until after I will announce winners after Caitlin Ahrens' talk. So let me quit sharing. There we go. All right. Next up, How about Jim Fordyce? I would love to hear some of the latest on Alcon and what's going on.
Good evening. Yeah, this is Jim Fordyce. I'm the president of the Albuquerque Astronomical Society and chairman of the Alcon 2022 committee. But I'm really happy right now because something very odd for Albuquerque and New Mexico is happening right now. Just started happening while Terry was talking, and there's this thing called water falling out of the sky. They call it rain. The first thunderstorm of the year here at my house.
Wow.
So we do get rain from time to time, so it's happening. Let me get the slide sharing here going. Hold on just a second. There, can everybody see my slide?
Yes.
Okay, good. So this is our logo for the Alcon. We've got Cocopelli with some planets coming out of his head. Looking through a nice refractor and looking at some constellations that you probably recognize. Where we're going to be and when is from the 28th to the 30th of July of this year. We will be at the Embassy Suites Hotel. It's a very nice convention facility located just about the middle of Albuquerque. And we have some great room rates as little as $129 a night for a suite room, either a single or a double. But those rooms are only available through the 24th. Now, the good thing is we have just very recently met our minimum number of room nights that we needed to provide to the hotel. So that's great, but they're still selling rooms. They're available, but only through next week, Friday. So get hot and get your reservation in. You can find that on our Alcon website, right on the front page of the homepage. There's a link to the place where you can make those reservations with the Embassy Suites. It's got a lot of amenities. It has complimentary Wi-Fi. You get your own cook-to-order breakfast every morning, and there's also a complimentary evening reception. Even though we're probably going to keep you busy in the evening, so I'm not sure you're going to make it to that. But you never know; you could just zip by and get yourself a nice drink on your way to the next one. Very nice place. Our registration costs are listed there for singles, couples, and students. That registration includes access to the ballroom for all of the speakers. You'll get a nice conference souvenir bag, as well as a nicely printed program, which I just sent to the printers yesterday, and we're getting that ready to go. You'll also get a nice lapel pin with that logo on it that I showed you earlier. And you also are able to come to the 27 July welcome reception. So that's on the Wednesday before the conference starts. And we'll get to meet you there in person. Keep in mind that conference registration closes on 6th July. That's the last day that you can make an order online. However, if you want to mail it in, those need to be postmarked no later than the 27th of June. So that's just 10 days from now. So we're getting to the point where you're not going to be able to get it in if you don't get it in soon. We have a full schedule. Picture here is of Glenn Chappell from Astronomy Magazine. He's going to be talking about the Variable Star Observing Program from the Astronomical League. He's been involved with that for many years, and apparently has a lot of good stories to tell about how he's done that and why, and that should be a lot of fun. He's a very interesting gentleman. We start off on Wednesday, the 27th of July, with an AL Council meeting. So Terry and Carol and folks like that, Chuck will be there to talk all day about how to make the Astronomical League better. We will then have that welcome reception that I just told you about. And then that evening, you can come down to our observatory. It's called the General Nathan Twining Observatory, or GNTO, for some observing at night. Now, keep in mind, it's July, so it's not going to get dark until a little bit after 9 o'clock. So you have plenty of time to get down there. And we have vans that are going down there. You can buy a ticket to ride in the van. We have a vendor expo every day. We now have, I think it's 7 or 8 vendors have signed up with us. and we're hoping for more yet. We still got about another month to corral a couple of more in there, and looks like we've got some real good ones, including, of course, the Astronomical League booth will be there, so you can buy all the Astronomical League things that you have been just waiting to see in person before you buy them. The conference itself starts on Thursday, the 28th of July. Our reception desk, of course, will be open then. It'll also be open on Wednesday for you to check in. We will start off with a workshop on the progress made at New Mexico observatories, as well as 5 speaker sessions, including Glenn Chappell there that I already talked about, and that GNTO Star Party. Again, so we're going to do a Star Party both on Wednesday and Thursday at GNTO. Then on Friday, we will have the AL annual meeting. So that's a kickoff for the day, along with an astrophotography workshop. And then we'll have 3 speaker sessions, including that last one, panel discussion with our president, Carol Lorge. And then that evening is a real special treat for the conference, is astronaut Harrison Schmitt. He's the Apollo 17 astronaut. So he was the last man to first step onto the moon. And he is a very interesting speaker and talker. We have 2 things going on with him. There's a VIP reception with him where you can get a copy of his book and get it signed by him, get a picture taken, hopefully. And then we will have him giving us a talk after a dinner. And then following that, we will have an observing session at Valladoro. It's a national wildlife refuge on the south side of Albuquerque. That is the first place to be designated as an urban night sky place. It's a real nice place. They just opened their brand new visitor center. It's very nice. And I think we'll have a real nice time there, looking at some stars to finish off the day. And then on Saturday, the big thing will be Seth Shostak talking to us about why we haven't found the extraterrestrials. He's with the SETI Institute, so apparently he knows something about that. And we'll see what he has to say about why we haven't found any yet. He's supposed to be a really great speaker, and we're looking forward to that. That will be at the awards banquet that night. We'll start off the day with the Observing Award Coordinator meeting, some presentations by those who have won youth awards. We'll have a photometry workshop and 4 speaker sessions. Some tours, trips, and special events that we have going on with this conference is firstly on Wednesday, we will have a tour of the University of New Mexico Institute of Meteoritics. It's a really great place to see some meteors. They've got a collection that's just really unbelievable. I've already talked to you a bit about the General Nathan Twining Observatory Star Parties. GNTO is a 4-acre, real nice dark sky spot about 40 miles south of Albuquerque. We've got both main and imaging domes on the site. The picture there, the upper picture, is of our main dome. And we have 22 observing pads. A lot of those pads will have a telescope on it from a task member so that you can take a look at our nice dark skies through those telescopes. We also have some people that have coming in from out of state who have contacted me and said, hey, I want to drive down to the site with my telescope. That's possible to do. It's explained how to do that on the website. And so if you're driving to town and want to bring your telescope down to our observatory, we can arrange to make that happen. On Thursday, we will have a tour of the Rainbow Park. That is the Rio Rancho Astronomical Society observatory. That is, of course, in Rio Rancho, and they'll tour you around their facility if you're interested. Here's a list of our other speakers. Those people I've said, 4 or 5 speaking sessions every day. I'll let you take a look at that for a minute. Really a nice slate of different people. You may notice that Chuck Allen, our Astronomical League Vice President, will be giving a presentation on observable universe scale. He's been asking me all kinds of questions about how big the room is and just what's going on. He's got a real fandango going on. That's going to start off on Friday morning. That is one I think you don't want to miss. But a lot of very other interesting things there. One I'll also point out is Ann Finkbeiner. She is going to be talking about her book that's titled A Grand and Bold Thing. It's a book about the Sloan Digital Survey. I just really liked that book. It was a lot of fun. Of course, I also like it because it all happened in New Mexico. And so it's close to home. And Ann has just got a real good thing going on there. I think it's going to be a great presentation. And lots of other very interesting folks talking as well. Some other tours and trips. We have Harrison Schmitt talking to us on Friday. I mentioned that. There's a picture of him when he was actually walking on the moon, and then a picture more recently. He's in his mid to late 80s, I believe now. Still going strong, very engaging, really fun guy to be around, and well worth coming to be in his presence and hear what he has to say about his time on the moon. We'll also be going down to Valladolid that night after Harrison talks. There's plenty of time. You can do all that, listen to him speak, and then get on a van, ride down to Valladolid. It's actually pretty close to the city, and do that and wrap up your evening by about 11 p.m. And then on Saturday, of course, we have that awards banquet that I've already talked to you about. That's going to be kind of the nice end event for the conference. Though we do have one more thing going on Sunday. We purposely did this after the conference is over because going down to the very large array and seeing that great collection of radio telescopes, it takes all day to do to get down there and take a look and get back. We have two different packages. You can just do the tour itself. You can go down there, you can ride a bus, real nice, comfortable bus, and you'll get a lunch. And we'll get you down there. You can see the VLA and get you back by about 6 p.m. or so. Or you can do what we call the tour and observing, which is all the above. You'll actually leave a little bit later in the day because we're going to keep you down there, have you go through the VLA, finish up in the later afternoon. We'll then have you have a dinner in Pie Town, New Mexico. Which for those of you who've been to Pie Town is famous for its pies, of course. And we will be also including in that the Lyceum tour. The Lyceum is a place in Magdalena, New Mexico that has been put together by a guy by the name of John Briggs, which I'm sure many of you know. He's been in the astronomy business for his entire life, and he has a collection of books and telescopes and all sorts of paraphernalia associated with astronomy that he has put out for observation. That is just amazing. It's really quite an interesting place to visit and walk through. And then we'll follow up all of that night by going out to a place close to Pie Town. That's why we're going to have dinner there, because this 40-inch Dobsonian that we're going to take you to, that's shown in the two bottom pictures here, is a heck of a telescope. John Briggs, who's looked through just about every telescope in the world, as far as I can tell, said this telescope is just really something. He has had a chance to get down there and look through it, and he says it really is worth getting down there. And so this is something that you want to come down and see and take advantage of. We will get you down there, get you a couple hours of looking through the telescope, and then get you back into Albuquerque about midnight to 1 a.m. in the morning to wrap up the conference. As far as who's coming and how many people are coming, we've got currently 141 registered people. Excuse me, 100. I messed up there. We actually have 142. I added one in and I didn't change the upper number there. We have 84 people coming to our banquet. We've got 69 coming to that Schmidt dinner. We've got 25 people that have signed up for the VIP reception with Harrison Schmitt. And as I already mentioned, the hotel is very nearly sold out, but they still have a few rooms available for us. But once they get to the point where they just don't have any rooms, so you won't be able to get it at the $129 rate. but get in quick and get those purchased. The conference this year is a bit smaller than we hoped for. We were expecting somewhere on the order of about 250 people or so registering. So really looking forward to kind of the late surge. We need about 100 more people to send in orders and get us up to where we were expecting to be. But we'll have a good time no matter what. 142 people or 250 people or whoever we've got, I think we'll have a great time there. And this is my last slide here. This shows you how to get to the website. It's alcon2022.astroleague.org. You can send us a question at the email address that's on there. And there's my contact information as well. And back to you, Terry.
Well, thank you, Jim. I'm really looking forward to this. We actually had Larry Crumpler on virtual Alcon last year. He is an amazing speaker. Finding out about the Mars rover and all the information, it was amazing. I really enjoyed that.
He's very much involved with it day to day, working with Curiosity and Perseverance. So he knows what's going on, as of yesterday.
Yeah. He is an excellent speaker. So, but all the rest of them are too. Carol, can we make a note that council meeting needs to be over with in time for the reception on Wednesday night?
Yes, we will make sure of that. In fact, we've done a lot of the pre-work ahead of time before we get to Albuquerque. And Terry says she's going to hold me to that.
Yes, I'm definitely going to hold you to that. We have done enough Zoom meetings, at least to cut our meeting time down, hopefully a little bit, or at least delete one of our meetings totally if we're lucky. So yeah, it's amazing. We all kind of look forward to being there, and yet we find ourselves in meetings and we're trying to hurry up and get things just where we want them to be right now. So it will be a lot of fun for everybody, I think. So everybody, register, get your hotel room. That's one of the things I was concerned about, because when I registered for the hotel, they were filling up then. So yeah, get in there before the 24th, before the registration is over with, for the hotel especially, and for Alcon. So thank you very much, Jim. Carol, I plan on being at a council meeting before the reception starts.
You heard it here first. We are going
to
be.
Terry's going to be at the reception. All right. Thank you very much. All right. We haven't been gone that long, so I don't really think we need to do a 10-minute break before we go to Caitlin, unless Caitlin, you would like a 10-minute break. Do you need it to get ready or anything?
No, I'm good to go whenever you are.
All right. I'll tell you what, let's go ahead and let me introduce Dr. Caitlin Ahrens. Dr. Ahrens' research involves remote sensing of icy surfaces, including permanently shadowed craters at the lunar poles and planetary volcanism on the Moon, Mars, Ceres, and Pluto. She was actually, or maybe still is, known as Pluto. Oh, tell me what it is. Dr. Pluto?
Yeah, Dr. Pluto or Pluto Manager.
Yes, it's StarQuest. At StarQuest, we call her Dr. Pluto.
Yep.
Yep. She received her BS in physics and astrophysics and geology from West Virginia University in 2015, and a PhD in space and planetary science at the University of Arkansas in 2020. Caitlin is currently a NASA postdoctoral program fellow at the Goddard Space Flight Center and a member of the Lunar Reconnaissance Orbiter Diviner Science Team. In 2018, she received one of the 10 Outstanding Young American Awards by the U.S. Junior Chamber for her efforts in science outreach. And I can tell you, this girl does outreach, and she does it very, very well. I've known her since she was in high school, and it was incredible just to watch her grow into an adult and the things she does. She really was one of those people that you stand back and say, man, I can't wait to see what she is going to do. So, it's been a real pleasure just being around you and, watching you grow up, and your mom, your family's just amazing. So let me hand Dr. Caitlin Ahrens over to our audience.
Thank you so much, Terry, for that introduction. And I gotta say, I definitely grew up with the Astronomical League too. And so, any young folks out there listening in, the Astronomical League is such a resourceful organization and use it to your benefit. We are so widespread, to be sure, but be involved with your local astronomy club. It will help, and it'll keep you fascinated. Don't ever think of it as something that you have to do, and never think of it as a chore or a job or anything. Just be purely curious and be involved with your local astronomy club. And who knows what all people you're going to meet. Being involved with the Central Appalachian Astronomy Club for many years now, over a decade now, and to the present, I've met some incredible astronomers that have eventually helped me through my career. So you never know. You never know. But go and be involved with your local astronomy club. All right. So let's get started with some Meet Mars stuff tonight. So this evening I'm gonna chat about just weird Mars geology. What in the red world is going on here? So I'm not going to dwell too much about rover updates or anything like that. Not too much though, because goodness gracious, that could take several hours just going through the rovers alone. But I want to kind of touch base as to like just how weird Mars is. Like the surface geology of Mars is just incredibly weird, incredibly fascinating. And there's still a lot that we truly have no idea what in the world is going on there, or rather what in the red world is going on here. There we go. So just a little bit about Mars. It is a rocky planet. It's about half the size of Earth. It can get pretty chilly though, negative 230 degrees Fahrenheit at its coldest. So yeah, a little bit chilly there, but you know what? It can get pretty balmy at some points around the equator. Typically, no more than 70 degrees there. Very, very thin atmosphere. It does have seasons, and I'll talk about seasons here in a bit because there's no trees on Mars, so it's not like you can like, oh, hey, the tree is turning colors. No, there's no trees with that kind of season kind of deal. So what kind of seasons are we actually dealing with on Mars? I'll talk about later. A whole day on Mars is just a little over 24 hours. It's 24 hours and 37 minutes. So not too bad if you are to have a Monday on Mars kind of deal. But a whole year takes 687 days. So not very, much a long time span in between birthdays, if anything. And it does have two moons, and I put moons in quotations here because Phobos and Deimos are captured dinky little asteroids. So they're not true natural satellites like our moon is with Earth. But I love showing this particular map of Mars. This is from 1877 by Schiaparelli. He used an 8.7-inch telescope to create just this beautiful full map of Mars. But interestingly enough, though, you just see all of these crisscross lines and everything. And there for a while, we just called these canali or canals, thinking that there's got to be some beautiful waterways, maybe tunnel systems, aqueduct systems all over Mars, and just all these very intricate, almost architectural structures all over Mars. Now, most of us being, amateur astronomers here, and if you look at a telescope through an eyepiece long enough, start to get some, little crisscross images in your vision, right? Especially if you're like staring at a bright moon for several hours, you start to get the little, wibbly woos in your eyes. Turns out that's pretty much what's going on here from Schiaparelli is those canals aren't necessarily there. Now the darker areas those are almost spot on. He might have seen some of the darker regions of Mars. Some of the volcanic regions on Mars are typically a bit darker. The poles on Mars are lighter compared to the equator, but those very intricate canals, nope. That's unfortunately an optical entity there. But beautiful, beautiful Mars. Many missions since then to bring us beautiful images and maps. So much data to still be had with Mars. But alas, no canals, no river boats going through Mars anytime soon. So, oh well. But what we do have as of 2011 is some of our beautiful geologic maps. So these are some of the maps that I work with on a daily basis, both on the moon and Mars, and so on and so forth with other planets and moons through the solar system. Every single color that you see on this map is a different geologic thing. This is so interesting. It's so multicolored. If only Mars was actually this colorful, that would be astounding. I would love to know what the purple regions are, but alas, no, you get 50 shades of red at this point. But with Mars, though, just how very intricate and beautiful all this geology is. And then someone had to take the time to map out all of this geology, and we're still finding new things. We're still learning about each of this geology. So just because it's all mapped out, it's not like we're just kind of going like, okay, we're done. Now what? No, far from it. If anything, this map is a good starting point, and there's still much more to add or to understand. So just kind of going real briefly through some missions here. So we've had quite a bit of missions here. And plenty more too. So what I don't have included on here is like the HOPE probe from the United Arab Emirates. But there's still a lot more missions to be planned in the future as well. So we've had a few flybys. What I mean by flybys, though, is you pretty much truly fly by and take as many pictures as you can, and then you just keep going, or you crash. Orbiters, you go around the planet a couple times, take as many pictures and measurements as you can, and eventually crash. And then you have your landers and rover systems. So quite a few. Now, most of these are already, sadly dead missions now. So flybys, yeah, okay, they would have already flown by. Okay. Quite a few orbiters are already decommissioned. We've already lost Spirit and Opportunity. Brave little rovers there. Our Phoenix lander, unfortunately, didn't last that long either, though. But you know what? We still got Curiosity. We still got Perseverance and Ingenuity. So we're still doing rover wheels on the ground, or in case of Ingenuity, propellers in the sky. We're still going strong there. So who was first? So this is an interesting little tidbit here, though. The Soviet Union launched 9 different probes from 1960 to 1969, while still going through space race to the moon at this point, too. But unfortunately, all of those probes had failed as far as communications, or just completely just crash landed. We didn't understand orbit mechanics of Mars just yet. We didn't really fully understand Mars's atmosphere at the time either. So, oh well. Finally, Mars 2 in 1971 finally landed on Mars, but it died very shortly after. So that didn't work either. It wasn't until finally Mars 3. I put an asterisk here, a soft landing. It kind of did a nice little tumble there. But you know what? It lasted a couple seconds. It made communications okay. So finally, Mariner 4, 6, 7, 8, and 9. Quite a few flybys. 8 and 9 were orbiters. Finally, the very first photographs of another planet with remote sensors. Completely debunked the whole canal systems here as well, though. So let's take a look at the very first photographs of Mars, shall we? Yeah. Very, very fuzzy. And an interesting note I have here too is that all of the Mariner orbiters and flybys, it missed Olympus Mons and Valles Marineris. Now, granted, when you have resolutions like this, yeah, you know what? I can at least give them a maybe a bronze medal of like, good try. But the fact that you missed the largest volcano in the whole solar system, that's actually pretty impressive. So at least we finally got the first images of Olympus Mons from Viking, the Viking landers 1 and 2. They landed on opposite sides of the planet. And this was kind of our first kind of touch about astrobiology. At least we were able to confirm oxidation and a little bit of chemical activity to then imply, oh, there might be some biological implications here. But the Viking images are absolutely gorgeous to look at. I definitely encourage everyone to just go Google Viking images. They're really, really spectacular kind of images. Mars Global Surveyor, I have a special place in my heart for Mars Global Surveyor because that was actually the first planetary mission that I got to do any sort of research on. Back in 2012, I worked at the USGS in Flagstaff, Arizona. So worked on Mars Global Surveyor for a couple of years. Unfortunately, it had died. It had been decommissioned in 2006, but it gave us our first composition map. It gave us a magnetic field map. It told us a lot about the dust cycles on Mars as well. And it really gave us a really good basic map to help us figure out, oh, where do we want to land our Phoenix lander? Where do we want to put our future rovers, our future landers? So Mars Global Surveyor gave us our first really good maps. Especially getting ready for Pathfinder and Sojourner, which was 1997. So in context here, it was like truly just right after Mars Global Surveyor. You got Pathfinder and Sojourner. I'll give you guys size here in a bit because Pathfinder and Sojourner are really tiny. They're really adorable. But I will give you size comparisons just to show like, yeah, this Pathfinder is truly the size of like a toy poodle. So size comparison here, it's a really, really tiny little thing. But it did give us some wind data. It gave like very, very minuscule amounts of soil and rock kind of data here. 2001 Odyssey. This one was an interesting little mission though, but it really gave us a good nail in the coffin for mapping hydrogen in the polar region. So it's like, oh, okay, there's frozen water and carbon dioxide at the poles of Mars. Great, awesome. What in the world do we do about that? Well, I'll tell you, there's some weird geology there at the poles, but also climate cycles as well. You have so much methane and carbon dioxide and water ice is kind of sublimating and then freezing and sublimating and freezing. So those polar caps are very, very dynamic. Mars Express, again, really helped us out with the polar caps, though. In this case, really helped us out with, there's a lot more carbon dioxide in the southern pole than the northern pole. And I'll show you what happens when there's a big difference in geology and why that is. Two favorite instruments here would be the HRSC, the high resolution stereo camera, and Omega. Omega kind of surpassed the Mars Global Surveyor mineral maps. So then we had Omega mineral maps, and Spirit and Opportunity helped a lot with that as well. Spirit and Opportunity had an interesting run though. Very, very long extended life, more than we thought that they were going to be. So they had anything from weird minerals, ancient magma fields, soil layers, frost, dust devils. But eventually they all, well, died out, unfortunately. The thing about Spirit and Opportunity, though, that we've learned is it's not so much of like their size or anything. It's because they were solar powered. So their backs were completely solar powered, which is fine. It definitely let them keep going. But the thing about dust devils is that they pretty much just got buried in sand, and pretty much what happened. Couldn't wake up. But now we finally have our Mars Reconnaissance Orbiter. This beauty, big honking camera here. So anybody who's a camera fanatic out there, you would absolutely love the HiRISE camera. 19.7-inch aperture, about 30 centimeters per pixel resolution. This thing is gigantic and amazing. And I'll be showing a ton of pictures from the HiRISE images, which are freely available to go see and explore for yourself as well. If anybody has any cool 3D glasses at home, just the cheap blue-red filter 3D glasses out there, the HiRISE image gallery is starting to add more just view at your own home on your own desktop computer. Take it to a party or something. You never know. Just take some cheap 3D glasses and go woo with Mars geology. But the HiRISE camera, interestingly enough, it worked so well that pretty much the very similar engineers that worked on the HiRISE camera built a very similar camera for the Juno mission to give us our very beautiful high resolution, the swirly storm clouds over Jupiter. So it's pretty much nearly the same design as the HiRISE camera around Mars. So definitely go look at Juno images too, because those are really cool. Quick little shout out to Mars Phoenix lander. I gotta have a shout out to the Green Bank Observatory in West Virginia because they confirmed the landing transmissions from Phoenix going, I landed and I'm still alive, yay. The radio telescope was able to confirm, good, whew, it landed, okay, let's do science then. Phoenix verified at least the presence of water ice in subsurface, which I mean just soil layers going on there. It definitely gave us our first microscope imager with a lander as well. Then we finally have Curiosity, nice bigger rover now. So Spirit and Opportunity, again, I'll show you size here in a bit, but Curiosity, we're going bigger and badder. So it landed 2012. I want to say either late July or early August 2012. 13 different instruments. It was nicknamed the Ultimate Geologist. It won many engineering awards, not just for its incredible build and all the amazing instruments it has on it as well, but also because of its landing. You're trying to land a small car on a completely different planet. That was very much like nail biting, hair raising adventure there. But you know what? It worked. And we were able to improve that landing sequence for the Perseverance rover. But I want to touch base real quick about the tires on Curiosity, because we kind of skimped a little bit on the tire design a little bit. We figured, okay, you know what? The previous rovers had very thick tires. They got stuck in the sand easily. Let's thin out the tires. What could possibly go wrong? So I'll tell you what happened here in a bit. But something I want to point out, though, is, why would you put holes on the tires? Well, interestingly enough, these holes are on here for a purpose. They're not here for just, for aesthetic reasons or anything. No, this is all Morse code for JPL. So Curiosity could just roll along the surface with marking its tracks going JPL, JPL, JPL for Jet Propulsion Laboratory. But unfortunately, because we thinned out the tire treads a little bit here, we have some wearing on the treads going on here. So, and they're getting increasingly scary and bigger. So, you know what? Curiosity is doing fine. It may limp a little bit, but it's doing just fine. MAVEN, the Mars Atmosphere and Volatile Evolution Mission, got there in 2014, still working. It's an atmosphere probe, so orbiter here. It really gave us a good sense of that carbon dioxide shifting between the poles. Really gave us a sense of like, oh, wait a moment, the atmosphere is on Mars is kind of weird. There's cool cloud systems on Mars. It's thin, but it's not uniform across the whole planet. There's like thinner spots in some areas. There's metal bits in the atmosphere as well. So it's all sorts of weird. ExoMars is delayed. Oh wait, no, there's a second ExoMars. This is the first ExoMars. So first ExoMars was an astrobiology mission. It's tried to get there in 2016 with the Schiaparelli lander. Unfortunately, well, you know what? Technically, it landed. It just landed in several spots. So there's going to be supposedly another ExoMars mission in the works in the future. But yeah, so there's the poor Schiaparelli lander here and here and here and here and here, maybe that little bit there. Moving on. InSight. So the InSight mission is steadily declining, unfortunately. So it was a beautiful mission. Really gave us a good sense of the interior of the planet, what kind of Mars quakes are going on Mars. And yes, we were able to detect Mars quakes, not scary end of the world magnitude 12 Mars quakes or anything. Goodness gracious, no. I think the largest Mars quake we were able to figure out with InSight is about a magnitude 4. So pretty good shaking there to be able to detect that with Mars InSight. But why we want to know about Mars quakes is we're just assuming that the inside of Mars is similar to Earth. But in reality, we really don't know. So understanding the interior, the core, what kind of mantle system is even going on Mars. We know it's a dead planet geologically on the inside. It's dead on the inside. But in reality, though, we don't know much about the layers. What kind of layer system are we dealing with on Mars? So essentially, InSight is pretty much just kind of putting a glass to the ground and kind of tapping and seeing if it can hear anything. So the Mars InSight was, like I said, it's still an ongoing mission though, but it only has like a couple months to years left of its mission before it's decommissioned. Now, interestingly enough, though, the probe, the HP cubed instrument here in the heat flow probe, this thing was supposed to go down a couple meters worth down into the ground. And that would have told us a lot about the soil mechanics. It would have told us what kind of heat the soil might have been giving off, what kind of vibrations the soil, how compact the soil might have been. Problem with that is we realized that the soil was way tougher than we thought, which is exciting because, hey, that's data that we didn't have before. Okay, but there for a while, the probe got stuck. Actually got stuck several times, but the most recent time was like mid last year. And it got to the point where we had to get the one of the deployment arms to essentially hammer it into the soil to get it unstuck. And then I think, if anything, it just got it stuck in a completely different way. So, you know what? Lessons learned. We tried. It was still interesting nonetheless. And then finally, we have our Perseverance rover. Again, big rover here. So Curiosity being about the size of a small car, Perseverance rover is just slightly longer in its instrumentation, though a lot more instruments this time too. This thing is a massive, massive rover. But its landing site is just absolutely gorgeous. This is Jezero Crater. No, it is not this multicolored. Again, I really wish Jezero Crater was this purples and greens and oranges and everything, but no, alas, no, it is not. What you're seeing here, though, is a mineral map of Jezero Crater. So every color that you see here is a different kind of mineral, which is really neat. Would have been an ancient delta deposit. So some sort of flowing water would have had happened here and then outpour into this giant basin here. So this is the Jezero Delta here. But all of these would have been different kinds of clay minerals, different kinds of silicate minerals, different kinds of maybe iron and magnesium minerals. All of those different kinds of minerals. I could say rocks are rocks. But knowing what kinds of rocks we're dealing with, like clays versus irons and magnesiums and stuff, can really give us a sense of like, oh, what kind of like volcanic systems would we have been dealing with at this time? If you're looking at clay, a lot of clay minerals, there would have had to have been water involved to make the clay minerals. So really gives us a cool sense of what would have been here, what kind of materials would have been sloshing around in this basin many, many, many thousands of years ago. So just a huge swath of where all we have landed on Mars, and it really truly feels like we've barely scratched the surface of Mars. There's still a lot of different areas that we have yet to explore with any kind of rovers and landers. But you know what? That's the exciting part, is that there's constantly talks and workshops and conferences and group meetings about, okay, where do we want to go next? Where do we want to land such and such, and why? It's always the why. Why do we want to land here versus here? It took, about 2.5 to 3 years to even choose the Jezero Crater landing site for the Perseverance rover. It took many, many meetings and workshops to bring the Mars community in and form debates and debates and debates. We had over 100 different landing sites on Mars. Then they narrowed it down to only like 3 or 4 landing sites. And then the Mars community was kind of pretty much doing a voting and debate system with like, oh, well, this is why we should go here instead of here. And no, let's go here instead of here, and gotta give the reasons. And ultimately, Jezero Crater won. Not to say that the other sites aren't going to get a future chance, but there's still hundreds of different landing sites to still explore too. So this is where it gets I love this so much. So this is the size comparison of these rovers here. So way down at the bottom here is your Sojourner Pathfinder mini rover here. You got your Spirit and Curiosity size off to the left here. Then your this is Curiosity, and like I said, Perseverance is just a little bit longer size though, but height wise it's about the same. So giant rover systems that we're improving upon with Curiosity and Perseverance versus Spirit and Opportunity. Very, very strong holding there. I love this Mars Exploration Family Portrait as well. There's still so many different international collaborations with these Mars missions too, and there's still plenty of them coming about too. So finally, okay, now I can talk about how weird Mars actually is, or how I like to call pretty picture time. Here we go. So again, like I said, every single color that you see here on this geologic map is a different geology. I'm not going to go through every single geology because we don't have 5 hours to be here. But I'm going to at least hit on the highlights. And one of the most spectacular highlights on the planet Mars is the volcano systems of the Tharsis region in particular. So this is the Tharsis region here. So this is Olympus Mons, the largest volcano, not just on Mars, but the largest volcano in the whole solar system. After this PowerPoint, I'll show you guys a very simple size comparison of just how big, how tall Olympus Mons actually is. But the base of this volcano can pretty much swallow the state of Arizona. So nice, good size comparison there of how big the base is, at least. It's very tall too. Then you have your three lovely other volcanoes here as part of your Tharsis bulge here. So you got Ascrias, Pavinus, and Arcia. So nice little alignment here. You got some other smaller, what are called tholoi or tholai, little volcanic systems there as well. So really, really cute. If we were to look at an elevation map here, so the very whites and browns and reds are the very, very high altitude elevation areas. The blues and the greens are much lower elevations here. So this is why we call it the Tharsis Bulge, is just this huge, huge plate that has just been bulged up with these volcanic systems, and it bulged so much. There's so much pressure on this part of the crust to bulge upward that it pretty much helped crack a lot of this this canyon system here. This is Valles Marineris here. So yes, beautiful Olympus Mons yet again. Now, interesting center here. So typically when you think of a volcano, you think of just a one vent volcano system and you're done. But this has several weird holes here, and that's because Olympus Mons was so active in its prime that it would explode and the hole will actually collapse because it just had so much of an explosion. That it would collapse and kind of fill up or just scab over in a sense. But it would just keep going and then scab over and collapse and then keep going again, scab over and collapse. And it did this several times. It just kept making a new hole every time. So we call this nested calderas. It's just the pure activity going on and on and on and on and on. And so there's a lovely side view of Olympus Mons as well. So gorgeous, gorgeous volcano. Now, these are not just the only volcanoes. There's other large volcanoes as well, like Elysium Mons. There's also really beautiful lava flow morphologies as well. I love this kind of morphology here. This is part of, I believe, Arcia Mons, or part of Olympus Mons, I think. So you can get cliffs kind of dangling and sinking back in, and they're almost like floating. They're not floating anymore, but that's pretty much what they would have done at some point. Little itty bitty volcano domes as well. So they're kind of like little volcano pimples here and there throughout the northern part of Mars. You heard it here. Mars has acne. Yeah. Again, just tiny little domes, though, that could have been built up and then collapsed, and then built up and collapsed. Just all sorts of beautiful, beautiful geology. Again, most of these pictures are from the Mars HiRISE camera, which are freely available to go peruse at your leisure. This isn't necessarily a volcano system. I just want to show a mineral map of why craters are interesting. Now, I can say craters are just very fancy holes in the ground. Okay, but craters can really tell us a lot about what kind of weird geology is going on in the surface as well. Because if you figure there's special holes in the ground, it's how well it would have punctured the surface. What would have been excavated from the crater? And so seeing mineral maps around craters, we can see, what's called ejecta. So you have something just wham, hitting the ground, making a giant hole, and then stuff just going kableh all over the place. And that kableh is called ejecta. So you can have different kinds of patterns here. This is going to be now my official term of ejecta for craters now. I'm not sure how you would even spell that, but good luck to anybody out there. But you can have so many different kinds of weird patterns here. My favorite kinds of ejecta patterns out of craters are kind of stuff that looks like flower petals. So these flower petal looking ejecta, that's honestly due to a lot of ice or water that would have been in the soil. And whenever you hit it at such a rapid speed, it heats up that ice and water, and it fluidizes the ejecta, and it makes it all kind of fluid. So that's why it looks almost like flower petal-y looking there. And even off to the right here, all of this layered petaling going on there. So that could have also been done to ice and water as well. This is just how beautiful the high-rise images are. So again, we're looking at like 30 centimeter per pixel resolution here. Most high-rise images are just kind of a simple strip image here, but then you could just keep zooming in and zooming in at just how much detail is just in this one part of a crater. And this is not a typical crater. This is not just a very simple hole. It's because this crater would have had a lot of ice, might have had some salt in it as well, to make kind of a weird fluid, almost look like a fluid painting in a sense, if anybody has seen fluid art and fluid paintings like that. Another interesting thing that the rovers picked up with their mineral cameras are these little balls of fun. These are what we like to call Martian blueberries. These are not actual blueberries. You do not want to eat these little things. But the closest thing that we have to these on Earth are called Moki balls. So they're just iron accretions. They're iron balls, usually found in like river systems and whatnot. It's because the river would take clumps of iron and smooth it around and around and around and make a little snowball of iron. But we call these blueberries is because the mineral cameras on rovers, iron shows up as that kind of a bluish tint. So we love calling these Martian blueberries, but again, you don't want to eat these. I love this part of Mars. It is just absolutely gorgeous. So this is part of Noctis labyrinthus, which we call the crown jewel on Mars. This is probably the most beautiful pieces of minerals that you would see anywhere on Mars. This is somewhere close to Valles Marineris, but this is probably where you'll find your better minerals, if anything. So this, not of gemstone quality, but this is an opal field on Mars. So like I said, it's not gemstone quality by any means necessary here, but still very beautiful that we have opal on a different planet, to be sure. And then it's a whole field of opal in this particular spot on Mars. I had mentioned this briefly when talking about the iron accretions and the craters here, though, but there are some places on Mars that have quite a bit of salt in the soil, and so salt really makes weird mounds and soil dynamics going on here, though. So this is a piece of a salt field on Mars. Really, really cool. Now, here's another interesting geology that it probably sounds boring at first. These are dunes, essentially just very special piles of sand on Mars. But I promise it's way more interesting than I make it sound it out to be. These are very, very weird piles of sand on Mars. It's because Mars, because it has such a low pressure in its atmosphere and a very, very thin atmosphere, but with a lot of wind. it creates some really weird shapes with its sand. It makes weird sandcastles, if anything. So you can have really beautiful linear, stripy looking dunes. You can have dunes that look, very chaotic, crumpled up pieces of paper looking texture of dunes. But you could also have barken dunes, which we love to I have shout outs to Star Trek though, because it looks like the Star Trek logo with some of these barken dune fields. You can also have star dune fields. So star dune fields are typically within craters that have a lot of winds in different directions. And when you have winds in different directions, it kind of piles up the sand in this kind of scaly lizard scale looking pattern within a crater. But dunes are also an interesting way for seasons. So now we're going to get into seasons real quick. So there's a summer season and a winter season. So yeah, I know there's really not much to say. There's technically a spring and fall season as well too. But you essentially got your very warm summer and then very cold winter. Once it hits winter, a lot of beautiful dune systems just become completely encased in frost. And it's almost like it stands still in time. It looks really eerie, but they show up very, very bright because of all the frost. So you know it's winter when your dune field suddenly it crystallizes and glosses over. And okay, I guess it's winter now. Okay, cool. But when it turns into springtime, that's when the fun part comes out, because these dune fields with a layer of frost. Now imagine, if you will, a layer of frost comes in almost like a spooky fog coming in, and then just kind of settles and crystallizes over the dune field. As it's settling down onto the dune field, it traps nitrogen and carbon dioxide gases into the dunes. And then it sits there and it waits. And it waits and it waits all through winter until spring arrives, and that frost layer starts to sublimate a little bit, starts to vaporize off the dune fields. So what happens to that carbon dioxide and nitrogen gases? Well, it turns into this. It turns into what we call spiders. So spider season is a thing on Mars. It happens very quickly. As soon as spring arrives. We definitely know when spring is here whenever the spiders on Mars appear. Now, these are not actual arachnids, but what they do look like, they do look like that they're skittering across the surface. It looks kind of creepy. What these are is that it's that carbon dioxide and nitrogen gases that are trapped in the frost and in the dunes. And as that frost goes away, all that gas just kind of goes poof, like little itty bitty geysers, little dusty, dark, dusty puffs of little geysers. And as they go puff, they'll just kind of look like that they're dissolving, skittering across the surface, and they'll go away. But that's when we know that it's springtime on Mars, is when the Mars spiders arrive, which at this point, saying it out loud, it sounds like a B-rated sci-fi movie. So, someone out there go make that. But because everything's so dynamic, we also get dust storms as well. Dust devils really kicks up a lot of interesting dust patterns as well. Let's see. Yeah, good. Okay, so there it's playing. I love this. This is from the Spirit rover when it's back in 2005 in the Gusev crater. You see just a really interesting, beautiful dust devils just kind of gliding through there. So you get the main bright one in the center here, but you got a couple of them in the background, just kind of going through. There's another bright one. Oh, two bright ones back there. So really, really cool. And those dust devils really make some interesting tracks as well. So all of this really chaotic looking tracks all over the place. We teasingly call this the Etch-a-Sketch design. It's definitely, it's really hard to say Etch-a-Sketch to a bunch of undergrads nowadays because they have no idea what Etch-a-Sketch is anymore. It makes me very, very sad. But hopefully most of the audience out there knows what an Etch-a-Sketch is, to understand, just how bizarre all these patterns are with the dust devils. All right, so moving on to another very weird head scratcher of a geologic feature here on Mars. These are called recurring slope lineae, or RSLs. RSLs really gave us a very, very heated debate as to whether Mars is wet or dry. And was it wet in the past? Is it wet now? Is it dry in the past? Is it dry now? At what point in time was it wet versus dry? And so seeing these flows, are these wet flows that don't stay there? They will disappear. And then, as the name suggests, they reoccur, recurring slope lineae. They will appear back again and then disappear and come back again and disappear again. We see these in just a very few regions across Mars. I think the latest debate / theory is that these are dry flows, that something is going on the tops of canyons and craters that are just making bits and pieces of the crater fall and almost make dark streaks coming down into their valleys. But they still look really weird nonetheless, though. So all these really dark little streaks that you see here going downhill, all of this would be recurring slope lineae, RSLs. So the debate is still going, by all means. I think just the current theory right now is that these are considered dry. But it's a matter of like, well, if they're dry, though, could they still be wet in some cases? Could there be salt? And then if there's salt involved, salt would have had to have implied that it would have been wet at some point. So it's just going and going and going. Another interesting feature that does imply water at some point are gullies. So gully systems here, beautiful, beautiful gullies. There's gullies all over Earth as well. So we, as planetary scientists, will go and travel around the world to study Mars-like environments. So we find gully systems on Earth. The volcanoes in Iceland and Hawaii are very similar to volcanoes, some of the smaller volcanoes that we see on Mars as well. Lava tubes. There's some beautiful lava tubes in Arizona and New Mexico, very similar to what we suppose lava tubes would be on Mars as well. So we use Earth as a really nice playground to study Mars. This is a piece of terrain that we have no idea what to do with, and we truly just call it chaos terrain. We as geologists have no idea what's going on here. So we truly just call it jumbled up mountains, and that's about it. So this is chaos terrain, and moving on. So just the full aspect of just how weird some of this geology is on Mars. You can truly just look at these images for hours and hours and hours on end. There are some aspects that it's still pretty active every once in a while. We still get active landslides all over Mars as well at times. There would have been ancient glacial systems. Now, how ancient are the glaciers? That's still under debate as well. But again, we see these all over Earth, Iceland and Greenland and mostly through Canada. We see these on Mars as well. Just beautiful, beautiful. This is probably my favorite glacial looking like tongue there. Just a bunch of glacial material just kind of blah outward. All right, so this is also an interesting little head scratcher. This is called Swiss cheese terrain. It's mainly, and it will take your eyes some time to adjust. It does take a lot of practice to realize what's actually going on here. All of these pits that you see here are actually going into your screen. It may look like a lot of the blotchy parts are popping out at you. That's actually inverse. So all of those pits are actually going into the screen. It does, like I said, it does take some time for your eyes to kind of adjust and train your eyes to realize like where's the sun angle, and what aspect are you looking at here? But all these weird pits that you see here, we call it Swiss cheese terrain. It's weird. This is only found on Mars, and this is only found in the south pole of Mars. So this is where the carbon dioxide part comes in, but we still don't understand why, and we still don't understand how either. There are very, very few laboratories in the world that are trying to recreate this kind of effect with carbon dioxide ice at Mars temperatures in a laboratory to try to recreate this kind of feature. It's very, very difficult because we still don't fully understand what in the world is going on here. But it's so cool to think that this is only found in the south pole of Mars. Nowhere else in the entire solar system has Swiss cheese terrain. But we love this part of the Swiss cheese terrain. This is called the happy face Swiss cheese terrain, which it looks like one of those eat and perk smiley face cookies, right? So a quick little shout out to some Mars books that have been recently released. Shameless promotion here. If you're really wanting to dive into like the minerals and the physics of the Mars volcanoes, check out Mars: A Volcanic World by Springer, by the editor Springer, editor Giovanni Leone. I myself have authored 2 chapters for that book. So very fun adventure there. But if you're wanting to read more about just volcanoes in general throughout the whole solar system, I highly recommend Natalie's recent book, Fire and Ice. And you can find that on Amazon. Fantastic book going through the whole solar system and what kind of weird volcanoes are in the solar system. And with that, I will leave you with this link here. www.uahighrise.org. This is where you can find all the beautiful high resolution, high rise camera images of all across Mars. If you have a classroom out there and you want to image pieces of Mars for your classroom, you are able to have image requests with the camera system as well. So it's a fantastic activity for the classroom as well. So the high-rise camera is absolutely gorgeous. Truly, just look at images for hours on end. And with that, I thank you so much. And just real quick, just give you guys a size comparison of just how big Olympus Mons is using sticky notes. So if you were to have Mount St. Helens as the width of my sticky note pad here. So Mount St. Helens is about 1,300 meters high. Compared to Mount Everest, the size of this cube of sticky notes here. So pretty good size. Mount Everest is about 8,800 meters tall here. So if you have Mount Everest, this is Mount Olympus Mons here. So very, very big height wise compared to Mount Everest, which is 8,800 meters. Olympus Mons height is about 21,000 meters. So pretty big volcano, but it is the largest volcano in the whole solar system though. So it's fantastic. And thank you so much, Alcon, for having me on this evening to chat about the weird and fantastic geology at Mars.
Thank you, Caitlin. That was amazing. While Scott's looking at his screen, I got a quick question. The little blueberry, little itty bitty, how big are those? I mean, like BB?
Yeah, very BB size, bead size, but very similar. Some of them can be like musket ball size as well. So very, very similar to just Moki balls that you would find out in the Southwest.
Okay. Yeah, because I thought, wow, it looks like BBs almost. Yeah, that's pretty cool. So I didn't mean to jump in front, Scott, if there's any questions.
No, there's questions here. It's fine. Okay. I'm going back through the chat stream just to make sure, hopefully I don't miss anything here. People enjoyed your presentation. I know that. Yeah. I particularly enjoy the way you give presentations, Caitlin. So You make it fun and very extremely informative.
And you can relate to what it is she's saying, when she's talking
Absolutely.
size. Yeah, just like you did with Olympus Mons, the size. I mean, that is amazing, because
Okay.
it's hard to figure this to compare it to something in your mind. But when you did that, then that gave us a comparison where we understood better.
It was interesting to get comparisons with just household objects, and I'm also in the middle of moving, so trying to find objects that I haven't packed yet for this talk was a little bit challenging, but we got through it.
Yeah.
So this is from James Fullerton, watching on Facebook. He says, what do the fluid ejecta, given the slope of the volcanoes, tell us about the viscosity of the material that was once fluid?
Oh, fantastic question, considering that's exactly what I work on. Yes. So definitely the different kinds of ice. How much ice are you dealing with? How much salt are you handling in your soil? So all this different kinds of minerals can either make it very flowy, but then the more salt and then typically more iron minerals you have in it, it really gunks up the works. So the more chunky, that kind of flower petal morphology that you have with like some of the flows and some of the craters as well, it's really going to gunk up the works there. But ice, it's a great lubricant, so it really helps spread everything out. Now, we don't really see that much ice around the volcanic systems. Just to the north of Olympus Mons is where we start to get that divide into glacial territory. But how old those regions are still being investigated.
Okay. Another question from James Fullerton. Are there plans to put a stronger drill on a future mission?
Yes, absolutely. Yeah, we've learned through Mars Insight for sure. But drill systems are actually becoming an interesting technology for not just Mars, but we're wanting to go back to the moon. We want to send boots on the ground to the moon in just a couple years with the Artemis program. And so we're developing drills for Artemis. We're developing drills for future Mars landers and rovers. There's concepts out there to do drills for Europa and ocean worlds, something that has thicker ice shells with some of these moons of Jupiter and Saturn. So all this ideas of drill systems and the designs of drills are really starting to become a better idea and concept, and then hopefully from idea and concept into actually building it and testing it. So for now, most of these drills are like, yes, we do want better drills, but the design and concept of them are still being worked on. The next fantastic drill to come about would probably be Viper. So Viper is a volatile investigation. I don't remember what the P is for Viper. It's a very interesting acronym here. But it's essentially a rover for the lunar South Pole near Nobili crater. And it's going to have a drill system to drill into the bits and pieces of the ice. So that concept and design is going to be really fantastic to learn if that design works. And then hopefully we'll use that design then for Mars.
Great. Mike Overacker, watching on YouTube, asks, do dust devils on Mars show lower atmospheric pressure in the center like dust devils on Earth?
That's an excellent question. We are still trying to learn about that right now. It's a little difficult to try to chase dust devils on Earth, to be sure. But you know what? There are dust devil areas that we would try to set up wind measurements and whatnot. A lot of folks from the Applied Physics Laboratory, APL, go out and visit with those wind measurement instruments and try to chase Earth dust devils to understand Mars dust devils. As far as pressures go, I don't know that at the top of my head, but I do know that there is quite a bit of work being done currently of the differences here. We do know that we have some wind measurements from some of the rovers, especially from Spirit and Opportunity, who have had the either lucky or unlucky chance of being blown around from a dust devil. So you know what, it was mixed blessings for those rovers and dust devils.
So it knocked off, I guess, some of the dust off the solar panels, right? A little
Yep.
cleaning job, but I don't know. It would be interesting to actually hear the dust devil hit Perseverance, though. So.
Oh yeah, to try to listen to it. Oh yeah, that'd be really interesting. Or just a lot of, just yeah.
Okay, Jeff Wise watching on YouTube. Now, I'm not, he said, is it so big because of the low gravity? I'm not exactly certain what he's talking about, but
I'm
he
either
talked about something being big, I guess.
I'm gonna assume maybe volcanoes. In which case volcanic systems just growing and growing and growing. Gravity can help a little bit. When you have very low gravity, it can help with a lot of that building and building and building. Another thing that Mars doesn't have that we have here on Earth are plate tectonics. So our plate tectonics really help. Okay, we have volcanoes and earthquakes all over the place, but it essentially helps shift material around enough. Whereas on Mars, you get all that material to build up and then build up and build up and build up and build up. And your crust isn't really going anywhere. It's going to have to release in some way. Now, there's still a lot of speculation as to why the 3 smaller Tharsis volcanoes look like that they're in alignment. Could those have been similar to, say, like the volcanoes in Hawaii, where you had like hot spots, just kind of like, oh, made a volcano, I'm going to shift over here. Let's make another volcano. Okay, we're done making that volcano. We're going to shift over here and make another volcano. And so that's a favorite theory going on right now. But to understand how hotspots would have moved, and then why didn't it make any more than those 3, or did it move and make some of the smaller ones that are not necessarily in alignment and all this stuff? So all of that is still being investigated.
Yes. Again, Jeff Wise, he says that strange South Pole region looks like the soil was boiling. It is so flat with the pits.
It is the pits.
It is the pits.
But interesting thing that you said about boiling, though. So there are experiments going on, not necessarily with the Swiss cheese terrain, but with carbon dioxide ice. There is a moment where carbon dioxide ice can look like that it's boiling at a certain very low temperature and pressure. It does look like that it's boiling as it's sublimating. And the Open University in the UK have a very large Mars simulation chamber that can go down the temperatures and pressures of Mars, and they boil that carbon dioxide ice mixed with a bunch of different kinds of sand to simulate Mars, and just to see what would happen. And turns out that they're recreating landslide. They're recreating a lot of really cool different kinds of morphology and geology. They haven't figured out a way to create the pits, though. So stay tuned for that, I guess.
And that is the pits.
That is the pits.
So Carlos Hernandez, who loves to make incredible illustrations, planetary illustrations and other types of illustrations, says that Viper is the volatiles investigating polar exploration.
Polar.
Yes.
Yeah, that makes sense. Yeah.
I thought it stood for purple, but okay. Anyways, everyone says thank you very much. It was very interesting.
Well, thank you. Thank you so much for having me this evening and to chat about Mars geology.
Well, thank you, Caitlin. That was an amazing talk. Really appreciate it. It's always a pleasure to have you here. So, all right. What we are going to do now, before I forget, is to give the answers to the questions. So, on the first question, how many galaxies does the latest estimate say there are in the universe? I just read this week. So it said 200 billion in the universe. And Don Nab has got that answer, or the closest answer.
So Carl Sagan was approximately correct, right?
Probably so, yeah. All right. On July 17th, the moon passes 3 degrees south of which planet? And it passes south of Neptune at 9 p.m. Eastern Daylight Time. And Deb Wagner answered that question correctly. And on Sunday, June 12th, the Perseverance rover rolled up to some odd, intriguing Martian terrain. What did it snap a picture of? A rock shaped like a snakehead. One of the articles said it looks like it's out of Indiana Jones. It just looks like a snake coming out of the rock. And Rich Kraling has answered that one correct. So congratulations to you three. Somebody from the Astronomical League office will be contacting you in the next few days. So I would like to thank Jim Fordyce, the chair or leading the Alcon effort, and he is also the president of the Albuquerque Astronomical Society. Thank you so much, Jim, for the update. Can't wait to get there next month. And thank you, Scott, for everything that you have done to help all of us. And David Levy, written so many books, poet. We sure do appreciate him starting us off every show that we have had. And Carol Orge, thank you so much for being the president of the Astronomical League and the time you take and put in all the effort. It is greatly appreciated.
Thank you, Terry.
Caitlin, sure. Caitlin, as always, it is such a pleasure to have you here. Everybody enjoys your talk. There is so much energy and information in everything you do. Thank you so much.
Terry, if I
Thank
could just
you.
say a few words here.
Sure.
Caitlin is an example of someone who came through our awards program in the league, and she has gone well beyond that. And what an example you are, Caitlin, for our upcoming contest winners as we go forward. So well done.
Thank you.
Thank you. And I would like to thank everyone that is watching. We couldn't do this without you, and we appreciate you being there, all of your questions and all of your interest. Thank you all very much. And Astronomical League Live, because we will be doing Alcon next month, we're going to take a break. We're all going to be pretty busy over the next month, getting ready, being there, and finally coming back home. So we are going to pick up Astronomical League Live on August 12th at 7 p.m. Eastern Daylight Time. And please, everybody, join us at Albuquerque if you can, July 28th through the 30th. So many of us that you see online will be there, and it would be great to just meet some people that we know names, but we don't know the faces. So please join us if you can. It will be a lot of fun. Every time we have an Alcon, it is always a lot of fun. We meet new people, you make new friends, and you catch up with distant family, because it's like the whole community, we all know each other. So thank you all very much. Thank you, everybody here on AL Live. I sure do appreciate it. Scott, you got anything you want to say?
I just, it's an honor to do these Astronomical League Live programs, and I'm always happy to be part of it. So thank you.
Well, thank you. And we will see Scott out at Alcon. He will be doing some interviews with some of the award winners, interviewing some of the speakers. None of the talks, none of the, actual talks or anything will be online, but you're more than welcome to come on out. Registration's still open for a while. And you can tune in and watch some of the interviews. It's always interesting to hear what all the people that are there have to say. So Scott, we will see you in Albuquerque.
Yeah.
And thank you everyone else. I sure hope we see everybody out there.
Yeah, thank you. You know, one of the things I'll remind everyone, although I will be broadcasting some portions of the Alcon, it is not a replacement for actually being there. We will have short interviews with some of the presenters and the award winners and the movers and shakers of Alcon, but being there, you're going to see the full presentations. You'll be able to be at the banquet. You'll be able to rub shoulders with Harrison Schmidt if you want to. You know, you're going to make new friends and lifelong friends in many cases. And it's an amazing event, and you'll be hanging out with your peers. So consider, if at all possible, getting that plane ticket, making those reservations at Embassy Suites, and being there with us in July. So thanks. And I think that's all I have to say. Anything else, Terry?
Not for me. Anybody else have anything they'd like to say? All right. Thank you so much, Scott. Thank you, everybody out there. We sure do appreciate it. And everybody take care. Enjoy the weekend.
Okay. Thank you very much.
Bye-bye.